Hey folks, so this is the lesson video for section 10.2 that deals with the sum and difference identities. I opened up your notes video with the embedded question, so I'm going to go through that really quickly. You've already turned this in class, so there's no need to send me this one. My question in the notes video said, is cosine of angle A plus B the exact same thing as the cosine of an angle A plus the cosine of angle B? In other words, are you allowed to distribute that cosine? And what we find out, I asked you in the other video to use the values 30 for angle A and 60 for angle B. And so let's just go ahead and plug those in. And so if I have the cosine of 30 plus 60, we know that that's the cosine of 90. We know the position of 90 is up at the top of the circle, and the cosine value there is equal to 0. If we go to the other side, where we're not really sure if these two things are equal to each other, let's plug in the 30 and the 60 again. So the cosine of 30 plus the cosine of 60, you know where those are on your unit circle. 30 is the first spoke into the first quadrant. And so the cosine value there is going to be the square root of 3 over 2, and the cosine at 60 will be the value 1/2. Now you can look at this just automatically and tell that the two sides are not equal to each other, because there's no way in the world that the right side will ever equal to the value 0. So no, these are not the same. You cannot distribute a trig function to two angles if it has the appearance of this cosine of the quantity and then the two angles are added together. So in the notes video, I gave you several different identities. I just wanted to go through some of my shortcuts, the way that I verbalize this, so that through the video, when you hear me say this, you'll understand what I'm talking about. Whenever I'm dealing with the cosine of a sum or the cosine of a difference, you will hear me say, I apologize, let's try that again. You will hear me say cos cos minus or plus sine sine. By the way, notice that the pluses and the minuses do not match up. That is intentional. So cos cos minus or plus sine sine. My verbalization for the sine sum and difference, it wants to keep on moving that. I apologize. Let's try that again. For the sine sum and difference, I'm always going to verbalize that as sine cos plus or minus sine cos. Now, one comment here, when you're working on your homework in my math lab, you're going to find that they have the order slightly different. They have the sine times the cosine plus or minus the cosine times the sine. It is the same thing. You can tell that that's just the commutative property that has been applied there. And so my verbalization doesn't work as well with the textbook version, so that's why I don't use that one. My shortcut for the tangent sum or difference is going to be tan plus or minus tan all over 1 minus tan tan. So usually I will say tan plus tan all over 1 minus tan tan if it's the sum version. All right, so let's just jump right on into some examples here. Example number 1. Notice that it says to find the exact value. So that means that you're not going to be using your calculator here to get decimals. Remember, exact means no decimals. The goal, we've never worked with pi over 12s before. So what we want to do is we want to use two values to add together to be able to get the number 13 pi over 12. Now, I could use something like 1 pi over 12 plus 12 pi over 12. And that is the same thing as 13 pi over 12. But unfortunately, even though I know how to reduce 12 pi over 12, I do not know how to work with 1 pi over 12. So even though this pair does equal 13 pi over 12, it's not a good pair to use because ultimately I don't know how to work with one of the pieces. So what I'm going to choose, and there are multiple versions here. For this one, I've just chosen a sum because I felt like choosing a sum. That's the best reason I have for you. And so what I'm going to choose on this one is a 3 pi over 12 plus a 10 pi over 12. Now, understand, I could have chosen a different version. I could have chosen a 4 pi over 12 plus a 9 pi over 12. I could have also done some subtraction like maybe a 15 pi over 12 minus a 12 pi over 12. Now, because there's so many options, please make sure that when you're handwriting these questions, whether it be on your homework or on your next test, make sure that you are showing me the unsimplified version because there's lots of different options. This is what I'm showing right now. But then also show me what the simplified version is. So you'll notice I've taken 3 pi over 12 and I have reduced to pi over 4. 10 pi over 12 reduces to 5 pi over 6. Make sure that you show me both versions of this. Okay, so next what we're going to do is we need to use our identity. So I want you to go back up to your identity, and we want to use the identity that says cos minus sine, because this is the cosine sum identity. This is a cosine of two angles that are being added together. So we'll use cos minus sine. And so let's just plug into the identity. My first piece is going to be the cosine of pi over 4. My second piece, the cosine of 5 pi over 6. Minus the sine of pi over 4 times the sine of 5 pi over 6. Now we're going to need to use the unit circle for each of these places. So I've taken the unit circle and I've marked my two positions, the pi over 4 spot and the 5 pi over 6 spot. And let's go ahead and start plugging in. So the cosine of pi over 4 we know is root 2 over 2. The cosine of 5 pi over 6 is negative root 3 over 2. The sine of pi over 4, I'm sorry, I uncovered the wrong one first. The sine of pi over 4 is root 2 over 2. And the sine of 5 pi over 6 is 1/2. So now let's just go ahead and multiply. We know that order of ops says multiplying comes before subtraction. And when you multiply fractions, you multiply the tops, you multiply the bottoms. So if we multiply the tops and we multiply the bottoms, we're going to get negative root 6 over 4 minus the square root of 2 over 4. These are already common denominators, so I'm just going to take these and rewrite them with that common denominator. And this is the exact value for the cosine of 13 pi over 12. All right, so example number 2. This is the sine of 105 degrees. Since on the last question we chose a sum, on this one let's choose a difference. I don't have to. I just want to get some practice trying both of them out. So for the sine of 105 degrees, I'm going to choose the 150 minus 45. This is not the only option. You could have chosen 135 minus 30. The deal is make sure that whatever the two angles that you're choosing to use are going to be, make sure that it's something that's already on your unit circle, something that you already know how to work with on your unit circle. All right, so let's take our sine difference equation, our sine difference identity, and that's what we're going to use. So this is going to be sine cos minus sine cos. So that's the one that we're going to use. So let's go ahead and plug and chug. So we have sine of 150, cosine of 45, minus sine of 45, cosine of 150. We're going to need our unit circle positions for these. So I have both of my positions marked. Sine of 150 is going to be 1/2. Cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. And the cosine of 150 is negative root 3 over 2. Multiply, and you get root 2 plus root 6 all over 4. All right, moving on to example 3. For the record, the tangent questions are the ones that are the most tedious. So just be prepared for a bit of tedium as you go through this. But just because something's tedious doesn't mean that we choose not to do it. What I really want to talk about before I even deal with the tangent part of this is the fact that I'm using a negative angle here. So what I'm going to tell you next is the best way to go about working with a negative angle. You don't have to do it this way, but it is, in my personal opinion, the best way to work with that negative angle. Always choose subtraction. Don't try to do a sum on this. Only work with subtraction on this. Just come up with two things that will subtract to give you 5 pi over 12. Forget the negative for a minute. So for instance, yes, 6 pi over 12 minus 1 pi over 12 would give you 5 pi over 12, but it's not a good option because I can't work with both of those. So we could try something like 8 pi over 12 minus 3 pi over 12. That would be a good option. That would give us a pi over 12. If you want the negative, just put the smaller one first. So we would put 3 pi over 12 minus 8 pi over 12. Another option would be 4 pi over 12 minus 9 pi over 12, because 4 minus 9 gives you that negative 5. So those are all some options. The one that I've chosen is the 3 pi over 12 minus the 8 pi over 12. Let's make sure, again, since there are so many options, make sure that you show me the unsimplified version like I've just done, but also show me the simplified version. So both of these are going to reduce to pi over 4 and 2 pi over 3. Now let's take those and let's plug them into our tangent difference identity. So this is the one that says tan minus tan all over 1 plus tan tan. So we have tan pi over 4 minus tan 2 pi over 3 all over 1 plus those same two things, tan pi over 4, tan 2 pi over 3. Now I'm going to go over to the side to do the next part of this. I really only need to figure out what the tangent of pi over 4 is and the tangent of 2 pi over 3 is. So over here on the side, I've drawn my unit circle and I've marked both of those spots. And the first thing I've done is just to figure out tan pi over 4, and we know that that's 1. The second thing is let's figure out tan 2 pi over 3. Tan 2 pi over 3, remember, is y over x, or you could say sine value over cosine value. And so that's going to be square root of 3 over 2 divided by negative 1/2. And once we invert and multiply, we know that that's going to be the same thing as the negative root 3. So every time, in the next step, every time I see tan pi over 4, I'm just going to replace with a 1. Every time I see tan 2 pi over 3, I'm going to replace with a negative root 3. So going back over to the left side here, you have that 1 minus negative root 3. And then on bottom, you have your 1 plus that same 1 times negative root 3. Now let's clean this up. On top, that's just going to clean up to 1 plus root 3. And on bottom, that's going to clean up to 1 minus root 3. You remember that you cannot have the square roots on the denominator, so we are going to have to clean this up. You want to use conjugates to do that. So I'm going to multiply by the conjugate of the bottom over the conjugate of the bottom. Remember, this is legal because those are identical, and so I'm really only multiplying by the number 1. Foil on top. When you foil on top, you're going to get a 1 plus a root 3 plus a root 3. That gives me my 2 root 3 that you see, plus a plain 3. Go ahead and foil on bottom as well, but the outers and the inners will zero each other out, so you'll just have a 1 minus 3. Continuing to clean that up then, up on top, I'm going to have a 4 plus 2 root 3, and on bottom I'll have a negative 2. Please don't leave it like this. Go ahead and share the love, make 2 separate fractions out of this in your mind, and then you can reduce the 2 separate fractions to give you a negative 2 minus a root 3. Again, just to reiterate, tangent questions are going to be more tedious than the other questions. So, so bear with it and keep on going. All right, now examples 4, 5, and 6 are all the same type of example, just like examples 1, 2, and 3 were all the same type of examples. So let me point this out to you. Examples 1, 2, and 3 basically came from the left side of my sum and difference equations. Just the left side. So we worked with the left and we plugged into the right side. However, the next 3 examples are all going to come from the left side, the right side of the equation, the right side of the identity, and we will be plugging into the left side of the identity. Hopefully you know your rights from your lefts better than I do. So again, 1, 2, and 3, we dealt with a single angle and we split it into a sum or difference, and then we plugged into the right side of the identity. But I want you to take a look at examples 4, 5, and 6. In examples 4, 5, and 6, you're looking at something that looks like the right side of each identity. The first one says cos cos plus sine sine. Look at example 5. Sine cos plus cos sine, or sine cos plus sine cos. And then in example 6, tan minus tan all over 1 plus tan tan. So these are the right side of the identity. We're going to work on plugging into the left side of the identity. So let's head to example number 4 first. And like I already mentioned, we're using the cosine difference identity. It's the difference identity because of that plus sign there in the middle. The plus sign in the middle matches up with a cosine of angle A minus angle B. So here we go. This looks like the right side. If I write it like the left side, you've already seen that I've started it out. That means that we're going to have the cosine of the quantity 7 pi over 8 minus pi over 8. Those are already common denominators, so if we subtract those, we get the cosine of 6 pi over 8. 6 pi over 8 reduces to 3 pi over 4. If I want to find the cosine of 3 pi over 4, I need the unit circle for that. And so there's my position. The cosine at that spot is going to be negative root 2 over 2. Let's jump into example 5. Notice that this one is going to be my sine sum identity. So I've got the right side of the equation here, and I want to plug into the left side of the equation. So this is going to be the sine of 40 plus 50, which is the same thing as the sine of 90. We know that 90 is at the top of the circle, and so the sine of 90 is going to be the value of 1. All right, going into example number 6. Like I mentioned earlier, this is going to be using the tangent difference, but because it says tan minus tan all over 1 plus tan tan, this is going to be the tangent of an angle minus an angle. And so we'll have the tangent of angle A minus angle B. That's 80 minus my angle B, which is negative 55. Yes, of course, we'll want to clean that up to 80 plus 55, which is 135. The tangent at 135, let's use the unit circle for that, and we know that the tangent there is negative 1. All right, so for the next example, number 7, it tells us to write the function, write it as a function of x alone. Notice here that what I have is cosine of angle A minus angle B. So let's just use our identity, and the identity that we want to use on this one is going to be the cosine difference. And so let's plug into our cosine difference identity. So that'll be cos cos plus sine sine. And then what I will need to do here is I'll need to use the unit circle to figure out the pieces that I know. So the only piece I'm really looking at here is the 270 spot. We know that the cosine at 270 is 0. We don't know the cosine of x, so let's just copy it down. We know that the sine at 270 is negative 1. We don't know the sine of x, so we're just going to copy that down. Now notice that the entire first term is 0 times something, which automatically means that this is going to equal 0. And then the second term is just going to be the negative sign value. So we have 0 minus sine, which is just going to equal a negative sine of x. Okay, so similar concept here for example number 8, only this time we're going to be using the tan plus tan all over 1 minus tan tan. So first of all, let's plug in the top. There's our tan plus tan all over, there's the bottom, 1 minus tan tan. The only thing that we can look for is the tangent of 7 pi over 4. So using our unit circle, the tangent of 7 pi over 4 is negative 1. So I'm only going to plug in a negative 1 value. All of the tangent x's I'm going to leave alone. And so that'll be a tangent of x plus a negative 1 all over 1 minus tangent of x times negative 1. Cleaning that up just a little bit, that gives me on top tan minus 1, tangent of x minus 1. And on bottom, that gives me a 1 plus tangent of x because of the two negatives that are being multiplied together. This is written as a function of x alone, so this is as far as you need to go. You do not have to go any further than that. All right, verify the identity. This is a lot of what we did back in section 10.1. So let's continue on with verifying the identity. Now, the first thing that I want you to look at, we've never really had anything like this right here. So I just want to lead you down the right path here. The cosine of 2 times x is going to be the same thing as cosine of x plus x. We know that 2 times x is the same thing as x plus x. So now all I need is my cosine identity, my cosine sum identity. So this is going to be cos cos minus sine sine. So let's go ahead and plug into our identity. So it'll be the cosine of x times the cosine of x minus the sine of x times the sine of x. Cleaning that up, that'll give you the cosine squared of x minus the sine squared of x, and that automatically is like the right-hand side. Moving on to example number 10. Now for example number 10, the first thing that we need to do is we need to draw pictures that match up with our given. This is what we did back in chapter 9 when we studied that concept of all students take calculus. You remember that? We had a video on it. We also had it in class on multiple occasions. So the first picture that I've drawn here is going to be used for my angle A. Notice that angle A has to be drawn between 0 and pi over 2. So we'll go ahead and draw a triangle in quadrant 1, which is between 0 and pi over 2. And then the way I know where to put my numbers is going to come from this part of it using SOHCAHTOA. So the sine of angle A is opposite over hypotenuse. So my opposite value will be 3. My hypotenuse will be 5. This is angle A, so I'll put that at the angle at the origin. And then I need to find the missing side. And we know that the missing side on that is 4. Let's go do the same thing for picture B. Notice though that this time picture B has to be between the angles pi and 3 pi over 2. Well, that's going to be an angle that's in the third quadrant. And so we'll draw a picture in the third quadrant. We'll call it angle B there at the origin. Notice that what I've been given, my SOHCAHTOA here, 12 over 13. Again, opposite over hypotenuse. Now you could put 12 like this and 13 like this, but you do need to make sure that you decide where to put that negative. And since 12, is going down, then that means that this has to be a negative value. If you use the Pythagorean theorem, you'll find that your missing side is 5. But wait, it's going to the left. Please don't forget your negative. That's a really, really, really big deal. Okay, now the next part is a little tricky, and students don't like to follow my instructions on this, but I'm telling you, it will work better for you if you will do what I say, even if it's weird. So notice that the directions are telling me to find the sine of angle A plus B. This is part A, and that's what I want to do next. So if I want to find the sine of angle A plus B, whatever you do, don't look at your picture for this. Hide your picture and just write the formula. So I'm taking my identity for this and I'm simply going to write the identity down. So this is the one that says sine cos plus sine cos. And you're going to see here, let me hide my picture. Try to hide it. I'm hiding my picture and I'm going to write sine cos plus sine cos. Once you have that identity written, you can tell that you've got 4 different things that you need to find. You need to go find the sine of angle A. You need to find the cosine of angle B. You need to find the sine of angle B. You need to find the cosine of angle A. So let's go and find all 4 of those pieces. And now is when you can unhide your picture to do that. So only look at, for the first piece, only look at the A picture. And so the sine of angle A is going to be 3/5. For the next piece, look at the cosine of angle B. So this is where we are right now. Look at the cosine of angle B on that picture, and that gives you negative 5/13. For the next piece, let's go look at the sine of angle B, and the sine of angle B is going to be negative 12/13. And then lastly, look at the cosine of angle A, which is going to give you 4/5. Now your calculator will do the multiplying and the adding and all that kind of stuff. It'll give you a fraction answer. So I'm just going to kind of skip to the next step. And notice that your common denominators are both going to be 65. New numerator for the first term is negative 15, and for the second term is negative 48. Combine those up on top and you have negative 63 over 65. Okay, so then let's move on to part B. And once again, hide your picture to do this first part. For the tangent of angle A plus B, this is where we want to write down our identity, tan plus tan all over 1 minus tan tan. So let's come down here. Our picture is hidden, and we'll write down our identity, tan plus tan all over 1 minus tan tan. Folks, there's no math involved in that. Just simply write the identity down. Now, once you have the identity written down, now you can look at your picture because you need to look at your picture. Let me zoom out just a little bit more. And now we can plug into our identity. So the tangent of angle A and the tangent of angle B, that's what we need to find. Tangent of angle A is 3/4. Tangent of angle B, don't forget that's a neg over a neg. Somehow my negative disappeared up here. Let's put that back. Okay, and so neg over neg is pos, which gives you the positive 12/5. And then down on the bottom, you have 1 minus 3/4 times that 12/5. Again, your calculator will do a lot of this work. So I'm just going to jump to the answer here, and you will have negative 63 over 16. All right, now for part C of this question, notice that you are asked, in which quadrant is this angle A plus B? You know, I don't know what angle A is. I don't know what angle B is, and I don't know what angle A plus B is. But I am asked to find which quadrant it might be in. This again goes back to the concept of all students take calculus. So let's take a look at what we found so far. And the first thing that we have found is that the sign of this mysterious angle A plus B is negative. Go back to part A. Do you see how we found that the sign value is negative? And so we know that when a sign value is negative, that can only occur in quadrants 3 and 4. All right. The next thing that we find is that from part B, the tangent of this mysterious A plus B angle is also negative. That's what we just found out. My tangent value is negative. Well, again, according to All Students Take Calculus, tangent is going to be negative in either quadrant 2 or quadrant 4. So now it's a very easy question. Which quadrant is this mysterious angle in? It's in quadrant 4. So that'll be the answer then to part C. And again, I love part C. It seems very difficult, but folks, if you just simply go back to chapter 9, this is a review question from chapter 9 using some new stuff from chapter 10. All right, this is the lesson from section 10.2. So wait for the next one. It'll be coming out soon.